So looking at formats and versions of IP addresses. Now, IP addresses can be in two formats and two versions. We have what's called the IPv4, the IPv4 IP addresses. Then we have what's called the IPv6 IP addresses. Is that fine? We have IPv4 and what? And
IPv6 IP addresses.
Good. Which means you're going to say they are the formats or versions of IP addresses called IPv4 and IPv6.
All right.
IPv4 and IPv6 IP addresses. Those are the formats that we have. Now, it's important for us to know what the word IP stands for in full. What does IPv4 stand for in full? It's important for us to know.
IP.
So let's get the meaning of what IPv4 means. IPv4. IPv4, what does it stand for? So here you are. Let me share with you the meaning of what IPv4 means. So you see this? You see that?
Internet Protocol version 4.
Very good. That's what IPv4 means. So in my notes here, I'm going to write, and IPv4 stands for Internet Protocol version 4. And then IPv6 stands for Internet Protocol version 6. So let me get back to that notes we are looking at. Sorry. So these are the meanings. IPv4 stands for Internet what? Protocol version 4. Then IPv6 stands for what? For Internet what? Protocol version what? 6. Are you there?
Yeah. What's the difference between two of them?
What's the difference between two of them? Now, let me first give you an example of an IPv4 IP address. Then also give you an example of an IPv6 IP address. Is it okay? Then you see the difference.
Yeah.
Huh? So here, I want to create a table. That table will have examples of what? Of IPv4. IP addresses. Then also we shall have examples here of IPv6 IP addresses. So we'll try to give you a difference in their appearance, first of all, before we go, because we're looking at how they differ. They first differ into their appearance. Then later, they also differ into other in terms of other what? Factors. So an example of an IPv4 IP address is here. I'll put it in red. It is that can be 192.1.10.10.1.2. No, it can be that. That's an example. 192.10.10.1. Then an example of an IPv6 IP address can be this. Can be this. So if you look at the two, you yourself, do you first notice any difference between the two?
Yeah.
From what you're seeing, give me an example. What difference is there between the two? From what you're seeing.
IPv6 has more digits than IPv4.
It has more, it has more characters.
More characters.
How many characters are there? 1, 2, 3, 4, 5, 6, 7, 8. It has got 8 parts. 8 what?
8 parts.
It has 8 parts.
Parts.
This has got how many? IPv4?
3.
Very good. 3. I think 3. Count, huh? 1,
1,
2, 3, and 4.
4.
It has got 4
Oh,
parts.
wait.
It has got 4 parts. Are you there?
Yeah.
So
That's
IPv4 has got 4 parts.
yeah.
Those are the first 2 differences. That's the first difference, sorry. IPv6 has got 8 parts. Are you writing down?
IVP has got 6 parts.
IPv4 has got 4 parts. Then IPv6 has got 8 parts. Are you there?
Oh, okay. Yeah, that makes sense.
That's the first difference. You getting me?
Yeah.
The next difference is, are you seeing between the parts, the way they are divided? If I'm to make this bigger.
Yeah. Yeah.
One has got a dot. The parts in IPv4, the parts are separated using dots. You see that?
Yeah.
For IPv6, they're separated using a full colon. It's called a full colon. Full what?
Colon.
Full colon. Do you see that?
Yeah.
Very good. That's another difference. Another difference is, do you see that IPv4, if you look at IPv4 properly, it has only, the 4 parts have got only numbers. Do you see that?
Yeah.
The 4 parts have got only numbers. Are you writing or not?
Yeah, I'm writing.
Very good. So for IPv4, the 4 parts, each has got a whole number or a number.
Each part has got?
For IPv4, each part has got a number.
Has got a number.
Only a number. Like the 4 parts have only numbers. You understand,
Yeah.
Now those numbers are referred to as denary numbers. Denary. They're called denary numbers.
Numbers.
Denary means base 10. So you can say I've got 4 numbers in bracket, 4 denary what? Numbers.
Denary numbers.
Now, if you look at IPv6, for it is mixed up. It can use numbers or a mixture of numbers and letters.
All right.
Like here, this part has got letters now, DB8. Is it okay?
Yeah.
Now that is referred to as, so for IPv6, you can say it can use both numbers and letters in brackets, what we call, that is called hexadecimal what? Values.
Value.
So this one uses denary values, but this uses what? Hexadecimal values. Hexadecimal values means letters or numbers mixed with letters. Are we there?
Yeah.
Very good. Now next, there are some other differences we need to know. Now there are differences we need to know. They're just right here. That if we convert this into zeros and ones, like what we did before with you, remember the base 2 conversions?
All right.
Do you remember how to convert numbers to base 2? Remember what we did before?
Imagine numbers.
To convert numbers to base 2, don't you remember we are converting? I could get 1001.
Oh yeah, I remember that.
Very
I
good.
remember that.
So now, if you
Yeah.
convert, if you're writing down, write down. If you convert IPv4 to binary, are we there?
Yeah, to binary.
If you convert, are you writing?
Yeah.
If you convert an
Convert
if you convert an IPv4 IP
an
address,
IPv4.
IPv4, yeah. If you convert an IPv4 IP address to binary,
Address
binary,
binary.
it will have a total of 32 bits.
What?
It is just there on the board, on the screen.
Oh,
If you convert an IP address to binary, it will have a total of 32 bits. Where
well,
each of the four parts, will use
will
8 bits. Where each of the four parts will use 8 bits.
bits.
I will use a value of 8 bits. So an example is, for example, if I was to convert this now to like binary, it may give something like this. I'm just assuming now. Maybe give us something like maybe 11100011, then followed by maybe 10101010 like that. I'm just giving you an example, but these are not the accurate. These are not the accurate what base two values of these values. I'm just showing you. And if I were to convert this into binary, the first part, which is this, will have 8 bits like this, 8 zeros and ones. The next part also will have 8 zeros and ones. The third part also will have what? 8 zeros and ones. Like that. The fourth part also will have 8 zeros and ones. You see that?
Yeah.
It's just an example. So you find something like
Do I
that.
write that?
It is your choice, but I'm going to send you the video after this.
That's all.
Now, so here each part will have 8 bits, and this will give us a total of what? 8 bits means 8 zeros and ones. If I were to convert this to binary or base 2. So I could say e.g. converting this to binary gives. So let me get the real calculation of the bits for each. Yeah? Converting the IP address, IPv4 IP address that binary gives a binary IP address of, so let me convert it and I show you.
Right.
So I want to convert it here. 192 to binary gives us what? So 192 to binary gives us this. 192 alone.
192 is
Alone.
110.
Yes. So gives the IP address of, I'm going to show you later. It gives us the IP address of, just a minute. What about 10?
And if my network was like that.
So 10 in binary will give us this. In binary, 8 bits shall have 1, 2, 3, 4. That's what 10 will give us. So if you have 10 again, it means you shall get this twice. Then we shall get this also. And we put the extra zeros. So for 1, we shall have 1 here. Then we put 1, 2, 3, 4, 5, 6, 7. So this is what it will give us in binary.
This is just 10 only.
No, this is 92.
And 92.
This is 10. This is, I get you mean? It's
Yeah.
this.
Oh, so this is the whole IP address.
Combined. So this is 92.
Yeah.
This will be 10.
10. Obviously, 10 is the same.
This will be very good. And then this will be
and
1.
That's 1.
Binary, you understand?
Yeah.
So in the computer, this IP address will appear like this in binary. Outside the computer, it will be in form of numbers, called binary numbers, called the whole numbers. But inside the computer, it will be in form of binary bits like this. And these bits are 8. You see, the part of 192 has got 8 bits. The part of 110 has got 8 bits. The part of 10 again, 8 bits. And the last part also has got 8 bits in the computer. So together now, this one will give us what we call in total 32 what? 32 bits. Because 8 times 4 gives us 32. Okay? We have 8 bits 4 times. That gives us 32 bits. Very good. Now, when you move to the IPv6, with the IPv6 IP address, if you have to convert it here, so we're also going to try to do it. We're going to say, if you have to convert this to binary, what happens? Actually, we already have this here for IPv6, you see? For IPv6, it has 8 parts. So when you convert
8 parts.
Yeah, it has 8 parts. Remember I said it has got 8 parts.
Oh.
Yes. Don't you remember this? 1 part, 2nd part, the 3rd part, 4th part, 5th, 6th, and 7th, then 8, the 8 parts.
8.
Now when you convert it to binary, each of the 8 parts will use 16 bits. 16 zeros and what? Zeros and ones. Let's take an example. Assuming we have an IP address like this for IPv6. Assuming we have an IPv6 IP address like this. 1, 2, 3, 4, 5, 6, 7, and 8. Assuming we have an IPv address like this. 8 parts. You seeing that?
Yeah.
Now, if you are to convert this into binary, it means that now I'm going to give you the equivalent. Do it here.
Wait, let me first come back. Let me first use the bathroom.
Okay, let me suppose this. And you come back to tell me,